All right, you maggots, listen up. Now, a few people have mentioned that they're telling me that I have a lot of knowledge. Yes, because I've actually done the experiments. You see some of my videos. When I get a thought in my head, I actually do the experiment. If I'm reading an article and a person says, I discovered this or that, I actually build that circuit. Other people just read it and they regurgitate it and they have 10 stories they tell, they have buzzwords. That's not me. I told you, what I talk about is what I've done, not what I'm going to do. What I've done or what I'm doing. Now, someone asked me, go look at the comment section. They said, well, what about uh, Torroid coils I've salvaged? Now, I'm going to try to give you a pretty good uh, explanation of what you're actually finding. All right, hopefully, because I'm getting older. I told you I'm 72, and you get cognitive decline. You notice in my video, sometimes I go in a circle. I'll tell you the same thing just after I got done telling you the same thing. That's all part of it's like an Alzheimer's. As you get older, you get dumber. And I'm just wanted to show you and tell you some of the things, toroid coils I pulled out. Now, this big honking heavy toroid coil came out of a power supply. You'll see them in there, switching power supply for a computer, or maybe even a printer. Now you notice there's extra wires on there. That's because I turned this into a switching supply transformer real quick, making an experiment to make a power supply for a command radio. And I did everything, I basically did what the person did. And then I realized this thing made so much noise that I went with an analog, two separate transformers to make the power supply. See, this became an experiment to realize I'm not going in that direction. I'm going to go old school on the power supply. All right. So this was an experiment just to verify that I don't want to put a switching supply in a tube radio. And that's why both my command radios, I come up with a power supply, and the BC348. So this is one use of a toroid coil. Didn't end up going in a tube radio. But this is mostly iron. When you look at this thing, you can actually see it's really not ferrite material. It's some type of iron. Right? Now here's another one. This is just a choke. You'll see these inside of a printer or a power supply. And what this does, you have a switching supply, and then the windings go to diodes to become rectified, and then it goes through this to the capacitor. First, the diode, it goes to from the transformer, the switching transformer, to diodes, makes DC, goes to one capacitor. Then out of that capacitor, it goes through a choke, and just like a 60 cycle choke, but they're running higher frequency, so the choke can be cheaper and smaller. That's the whole thing about a switching supply. It's cheaper, it's smaller, and it's lighter. So that's it. So this is the choke that goes between the two capacitors. Yeah, my fingernails are long. Sorry about that. Very eccentric. After I do this video, I have to go mow the lawn. Let me snap back to this. So anyway, this is a choke. And this, the only thing you could use this choke for, or this, if you rewound it, it's basically the same frequency range. It'd be in the kilohertz. It'd be, whatever the switching supply is switching at. It's usually more than 1,000 hertz, the switching supply. Read up on switching supplies, but that's what you could use this one for. Between the two capacitors, the main capacitor from the diodes, and then goes through this, then to the final capacitor, and then maybe the final capacitor has some 0.01s across to get rid of some RF. So you got to watch out for RF. Now, these little rabbit turds, let's call these rabbit turds. I don't know if they're showing up in the, yeah. They have a hole through them, and you put these on a wire, like if you have a circuit, an RF circuit, and you put this on a resistor on the lead, that becomes a choke. And you're like, what? Yeah, it becomes a choke. And that's what they do a lot of times. So when you see these rabbit turds, I don't know what they actually call them, that's to prevent that resistor and whatever it's hooked to from going into self oscillation. A lot of times when you work circuits, high frequency, even if they're laid out right, when you turn the power on, the thing starts to oscillate, and it's an RF amp, but it's oscillating, and that's because you need to keep it from self-oscillating. You only want it to amplify the frequency you want it to amplify. You don't want it to become an oscillator, and that's what these are for. And these also, you'll see these sitting, coming off on connectors going out of a computer, and that's to choke off any RF that might get out of the computer, and the FCC makes them do that. All right, you have to understand. There's coils, which transformers, which are two windings. Um, a single coil would be mostly in the choke vein. You do have exceptions. Now this is a choke I made, and this is the core you tune in a coil, and you can make a choke out of it. That's how you wind it. So there's all kinds of. I've done all these experiments, and then these are little tiny ferret beads, ferret donuts, and a ferret bead, and these are chokes too, up at the VHF range. You might find these inside a TV tuner, a VCR up in the tuner section, and what they're doing is they're keeping RF from going out of the circuit back up into the power supply. See, anytime RF goes from your circuit back into the power supply, it can come back around and cause self-oscillation. It can also go over and cause another circuit to get noise. And you can I used to build TV decoders. Sometimes you get a line down the center of the screen. And that was something was getting back into the power supply. And then it was being amplified by an RF amp. And then it would get over into the vertical section, or the video section. And you'd have a line on the screen. And it wouldn't move because it was synchronized with one of the main signals. And then you would have to go find it and put a choke in. So I told you, I've been down these roads. I've done engineering on my own. I've engineered circuits. And the problem with electronic is, as soon as you get a circuit working good, it becomes basically obsolete. You got to really move fast. I did make a circuit board called the Piker. It was a motor driver. Did 4 motors, 4 stepping motors. I was milling them out with the CNC machine and selling them, and then I had them produced in Texas. And I won't say they became obsolete right away. It was basically a beginner circuit, but I couldn't make any profit with it because the circuit board company that I hooked up with wanted, in big batches, I had to pay $16.50 for each circuit board. Forget shipping. And in business, you have to mark something up 3 times. And I was only marking it up a few bucks. And people bought the circuit board. They never built it. So I used my retirement money on those circuit boards to make everybody happy, and ended up I got burned. I just, some of the stuff I've gone through, at the time you think it's a good idea. You think there's going to be a return, and there isn't. And that's what business is all about. Sometimes you get in a position where you think you're going to turn the corner, and the corner, when you turn the corner in business, it's worse. And then you realize you just put money down a hole and it's gone. And that's what I found out. That's why with the CNC, I sort of dropped back. I was still coming up with new machines and new designs, but people, they really wanted a machine just to screw with, make tugboats. So they bought 3D printers and they made tugboats, and they just wanted to stay busy. And then there were guys, what was it, Steve Manzer, Dave Cush. There's another guy, Steve Manzer, Dave Cush, and Gary Wheeler. Those 3 guys, you'll notice they in the comment section. I know those guys for years, never met them, just strictly over online with my different conferences. And they basically they follow what I do, and they do stuff too also. I won't tell you what they do, but they went out there, and I was following their websites and stuff. But this one here, you'll find these on a bale of wires that go to a connector, and this is RF prevention. And you say, what do you mean? Well, the FCC doesn't like RF coming out of a computer or a printer, so they put the cable through this. They go around once, in through here, and then this chokes off RF. It doesn't do 100%, but it passes the FCC, and then you have a transistor radio in the room and you can't use it, or an AM radio, you can't use it because this isn't 100%, and that's also what this is. Oh, and so anyway, so now we have all these different types of toroids. Now, when you find the toroid, now I have a great memory, still pretty good. When I find the toroid, I can actually look at it, memorize it, and remember where I got it from. In this case, this was a switching supply, and this was out of a computer, like an AT computer power supply. So I know what these things are. I know these came off of a bale of wires that go to a connector. Same with this one. And I know what they're for. And I know what the rabbit turds are for. So now, knowing that these are real low frequency for power supplies. So that's what these are. All right. These are for RF suppression. There might be a self-resonant frequency, but it's going to be muddy. That's what you have to understand. I told you to buy, here's one here, a T50-6. All right, here it is here. That's what it looks like. It's tiny. I showed you how to wind it. T50-6, it's yellow. You can make radios in the 80-meter band and the 40-meter band using this. You can use this coil for the RF amp and the oscillator. This is the mix that this is made out of doesn't expand and contract that much, and it's good for an oscillator. So temperature doesn't make the ferrite donut expand and contract, causing the frequency to drift. That's what this is. This is specifically made to be used in an oscillator circuit, 80 meters or 40 meters. Now, 80 meters is 3 megacycle area. Someone's going to argue 80 meters is like 3.5 megahertz. 40 meters is 7.2 megacycles. I don't have a ham license. I basically overlap their stuff. All right, now, so you get a bunch of ferrite donuts. Torroids. Camera works backwards on it. It makes me crazy. If I look over at the monitor, I notice I sometimes slowly drift off screen. All right, so anyway, you get some of these, and I found an article, and it says, for testing unknown toroid coils, take the toroid coil, remove all wire that's on it, put 10 turns of any kind of shielded wire on it, or insulated wire that'll fit on it. You can use magnet wire. I have that wire that's used for the telephone. I don't see any around here. But anyway, you put 10 turns on it, and then you have to have an inductive tester, something like this, and hopefully it does the range. You put it on here and you click the button, and it tells you how many microhenries it is or how many millihenries it is. Now, if it's millihenry, it's most likely one of these suckers. It's iron core. If it's microhenries, it's most likely something you might want to make a radio with. So that's how you test it. There's no other trick way. You do a visual inspection. You try to remember where you got them from. The guy said he's been salvaging them. Well, most likely you're getting them out of computer supplies. This is another one from a computer, switching supply, AT. And what I use a lot of these for, believe it or not, is I take the wire off them. I'll take the wire off and salvage it to make something else. That's what I'm doing. That's what these are for. I don't save them. Oh, I save a few just in case I want to make some type of switching supply, like I did. I made one. I did just like the guy had the schematic and the whole thing on his website, and I turned it on. It knocked the radio out. It does work on certain frequencies. See, you can build a switching supply and put it in a tube radio and turn to a strong station and say, hey, look, this power supply works. But then you go up and down the band looking for weak signals, and you can't hear them because the switching supply is everywhere. That's why I went with the analog supplies. I think I covered it pretty good. I'm trying to do videos that I know no one else has done. That's what I do. And they have these $40,000 labs. They sit with they're all dressed up. They sit there with their face in the frame. and they tell you stuff that you could see on Wikipedia. And I don't do that. I'm giving you what I've done myself with these stupid things, you know. And these are basically worthless. These little tiny chokes, VHS circuits, and VHS circuits now are usually surface mount components. But this is back in the VCR television days, the old TV days, and this is when they were getting more sophisticated. This might be out of the UHF channel selector, which didn't scare me. I've actually repaired UHF tuners and VHF tuners when the television lightning struck nearby and burnt stuff out. I've I've stayed with stuff just to learn, and a lot of times it's very painful because you never think you're going to get out of the rabbit hole. But that's how you learn, and then sometimes you learn to stay away from something and how hard it is, and then you start telling somebody, a neighbor or something, how hard something is, and they just look at you like they don't care if it's hard. They want you to take care of it because they don't know. And then they don't pay anything. They don't reciprocate with anything. That's what I learned in life, right? They browbeat you. Well, I guess I thought you would know how to do it. They have all these little sentences to pull your string. And they did it to me. I admit it. I thought you could figure it out. They have 3 sons in some cases, which don't know shit from Shinola. And then they're talking to me. Well, I figured you would know how to do it. Now, one of the neighbors called up one time, and she had an old television set. She wanted me to repair it. I said, I don't fix television sets. Well, what is it that you do? That's how she talked to me. Well, what is it that you do? And I started explaining to her, well, how did you get in there? How did you get in that field? Because her son was a doofus. All right? Her son was a doofus. He knew everything, but he said he knew everything, but he didn't know nothing. And he was a bullshit artist. And I got involved with him on something, and he got me pretty good. But when a person's talking technical around a whole bunch of old people, they don't know what he's talking about, so they don't know if he's bullshitting or not. He screws them over. Then I come along, and I'm trying to explain to them what we need to do to fix the problem. And they're looking at me like I'm the bullshitter. See, they've already had the experience with the bullshitter, and now he didn't fix it right. He's got them all screwed up. I come along, and I do fix it, and they don't even say thank you. That's one of my biggest problems lately. I notice I've been dealing with people that forget to say thank you to me. I think that's it. All right, that's it.